This is question 53 from the GATE 2019 EC paper, where we are given that a CMOS inverter designed to have a midpoint voltage Vi is equal to half of VDD has the following parameters. VDD equal to 3 volt, mu1 Cox is 100 microamp per volt square, VTN is 0.7 volt, mu P Cox is 40 microamp per volt square, and mod VTP is 0.9 volt. Right? We are asked to find out what the ratio of W by Ln to W by Lp is, rounded off to 3 decimal places. Underneath the question, you will find the title of the NPTEL course or video most relevant to this topic. Now, in a CMOS inverter, if you assume that these are long channel devices, right? This is between VDD and ground. This has W by L ratio P, W by L ratio N, right? And the midpoint voltage is the voltage at which the output Vout is equal to the input Vin. That is, the same V appears on both, right? And in this case, it is designed such that this voltage is equal to VDD by 2. We are simply asked to find what the ratio of W by Ln to W by Lp is. Now, for both these transistors, Vd is equal to Vg, that is for the NMOS and the PMOS, right? This is by definition of the midpoint voltage. This is the drains of both of them, and this is the gates of both of them, and both are at the same voltage. Of course, this means that for the NMOS, Vd is now greater than Vg minus Vtn, and for the PMOS, Vd is now less than Vg plus mod Vtp, right? So of course this means that both of them are in the saturation region. N and P are in saturation region, right? Since we have assumed that they are long channel devices, we don't need to worry about VDS and VDSAT and whatnot. So knowing this is enough to say that both of them are in saturation region. So all that's left to do is to write the two saturation currents. So this is the saturation current for the NMOS, and this is the saturation current equation for the PMOS, right? So what's on the left is the current going into the drain. This is the LHS of the equation, and what's on the right is the current coming out of the drain for the PMOS, right? Because this is the saturation current formula for NMOS and PMOS. Now we just need to substitute the values for mu and Cox, VTN and mu P Cox and mod VTP, and we can of course get that VGS and VSG are both VDD by 2, right? This is because the gate is at VDD by 2 and the source is at 0, and this is because the source is at VDD and the gate is at VDD by 2. So finally we get this expression, and we can get the ratio of WL by W by Ln over W by Lp on the LHS to get 4 by 10 into 0.6 square by 0.8 square on the RHS, which equates to 0.225. So if we round this off to 3 decimal places, it is 0.225, which is the answer to this question.